We are now in section 10.6, solving radical equations. So this is something that takes some practice. I'm not going to show a whole ton of examples of this. You'll probably be better served by watching the examples I do show 2 to 4 times, as the technique itself is not going to change from problem to problem. Some of the work is going to get more sophisticated, but the technique itself is largely the same. So we're going to go ahead and solve some of these questions here. Let's go ahead and take a look at number 7, and let's see how we do this. So number 7 is going to be the square root of 5x plus 1 is equal to 4. So we got to figure out, how do we solve for an x that's stuck under a radical? Well, what we're looking to do is to try to get rid of the radical. So what we're going to do is we're going to square this, and we're going to square this side. So we're going to square both sides of the equation. And as we know from earlier work, when you have a square root and a square, they undo each other. So here we'll have 5x plus 1, and then 4 squared is going to be 16. Now, once we do that, that's probably not so difficult to solve. We'll go ahead and subtract 1, where that's going to be 5x is equal to 15. And then when we divide by 5, x will equal 3. There's one thing that we do have to do for these problems, especially if you want full credit, and that's going to be a check. So what we need to do is to take whatever solution, or solutions, because sometimes we get more than one, and we need to do a check with them. And what we're going to do is we're going to take that value and plug it into the original problem. So it's going to be 5 times 3, because that's where the x is, plus 1, and see if we get that to be 4. Well, 5 times 3 is 15, plus 1 will be 16. And yes, the square root of 16 is 4, so that holds out to be true. That answer does, in fact, check out. So let's go ahead and just look at a few of the problems and take a look at some of the loops that they can throw in here. We're going to take a look now at question number 12. This is going to be the square root of x minus 2 minus 7 equals negative 4. So before we can do anything with this problem, we need to, or before we can get rid of the radical, we need to get the radical by itself. So what I'm going to do is I'm going to go ahead and I'm going to add 7 to both sides. And when I do so, that's going to give me the square root of x minus 2 is equal to plus 3. At this point, I can go ahead and square both sides so that I can get x minus 2 is equal to 9. And most of you could probably look at that pretty easily and recognize, well, here, if I add 2 to both sides, x is going to equal 11. Again, we want to be sure to do a check of this. So in place of x, we're going to put 11 minus 7 equals negative 4. 11 minus 2 is going to be the square root of 9. And we put it into the original form of the problem. Nothing that we've adjusted, because we may have made a mistake along the way. So we put in the original problem, and sure enough, 3 minus 7 is equal to negative 4. Our solution does, in fact, check out for this. So those are just 2 examples. Let's go ahead and plow through some more. Sometimes you may see a problem that has a 3rd or a 4th root. Well, let's see how we tackle one of these. Let's go ahead and take a look at 18. So 18 is going to be the 4th root of x plus 3, and that will equal 2. Well, if we're going to undo a 4th root, we need to raise something to the 4th exponent. So I'm going to raise this to the 4th. I'm going to raise this to the 4th. And what that's going to do is it's going to give me x plus 3 here. 2 to the 4th is going to give me 16. So at that point, I'm going to go ahead and I'm going to subtract 3. I'm going to get x is equal to 13. Again, if I do my check, I'm going to get the 4th root of 13 plus 3. That's going to give me the 4th root of 16. And 4th root of 16 is 2. So that solution checks out. So if you ever have something raised to the 4th, or if you have something under there that is to the 4th root, all you do is just take everything to the 4th, and solve it that way. Let's go ahead and take a look at a problem that kind of expands on this a little bit. Take a look at 34. So here we've got the third root of 3y plus 6 plus 7 equals 8. Well, remember, before I can take the third root of anything, I need to first get the radical by itself. So I'm going to subtract 7 from both sides. This is going to give me the third root of 3y plus 6, and that's going to equal 1. I need to get the radical by itself, and now that I have the third root of something, I'm going to cube both sides, and let's see what happens with this. That's going to give me 3y plus 6. Well, that's not too bad. The 1 cubed is equal to 1. From here, I'll go ahead and subtract 6 from both sides, where I get 3y is equal to negative 5. And then I'm going to divide by 3 to get y equals negative 5 over 3. I will let you, I'll show you the check for this one. Check looks worse than it is because we have negative 5 over 3. So we've got the third root, so it's going to be 3 times, and I'll write this as 3 over 1, times negative 5 over 3 plus 6 plus 7 equals 8. Well, let's see. This reduces, so we're going to have the third root of negative 5 plus 6, or just the third root of 1 plus 6. Excuse me, not plus 6. Yeah, third root of 1 plus 7 equals 8. Well, the third root of 1 is 1, and 1 plus 7 does equal 8. So this, in fact, does check out. Let's take a look at a few other problems. We made 2 to 3 others for the techniques for how to do these. Let's take a look now at 36. So 36 is going to be the quantity of 2t minus 7 equals 4t plus 3. And so we have radicals on both sides of the equation now. And essentially what this comes down to is we just need to square both sides. And by squaring both sides, we get rid of the radical on both sides. This is going to be 2t minus 7 equals 4t plus 3. At this point, it just comes down to the rules for solving equations. If I subtract 2 from both sides, this will give me negative 7 equals 2t plus 3. Since I have my t's here, I'll subtract 3 from both sides. This will give me negative 10 equals 2t. And if I do that, I'm going to go ahead and divide by 2, divide by 2. And then for this one, I'm going to get the solution of, hold on, just checking my work here. I get 2t, 2t. Just something about the answer I don't like here. Maybe I copied the question wrong. 2t minus 7? Yes, I did. So I took 36 and 35, combined it together. So cross that out with my apologies. 36 is going to be 2t minus 7 equals the square root of 3t minus 12. Let's see what happens with this. Principle is the same again. We're going to square both sides to get 2t minus 7 equals 3t minus 12. I'll subtract 2t from both sides to get negative 7 equals t minus 12. I'm going to add 12 to both sides, and I'm going to get 5 is equal to t. I'm going to sub it into the original equation, so I get 2 times 5 minus 7 equals 3 times 5 minus 12. And if you do your math correctly, you'll notice you get radical 3 is equal to radical 3. And that's fine. You can leave radical and still have both sides be equal. So that solution does, in fact, check out well. So let's go ahead and see what we do with the next problem, where this begins to get a little more complicated. Let's take a look at number 40. Here we have x equals radical x minus 1 plus 3. Notice here that the 3 is not under the radical, So I'm going to go ahead and subtract 3 from both sides. And what this gives me now is x minus 3 equals the square root of x minus 1. When I square both sides now, I need to square the binomial that results by subtracting 3 from both sides. So here, the radical is going to disappear and simply give me x minus 1. But when I square x minus 3, it's going to be x minus 3 times x minus 3, or x squared minus 6x plus 9. So we get that by taking x minus 3 times x minus 3 and then multiplying it out and combining everything together to get this. Now that I have this, I get a quadratic equation. I have to set this equal to 0 now. So I'm going to subtract x. I'm going to add 1 to make this 0. And now I get x squared minus 7x plus 10. So sometimes what results here is you get a problem that will result in a quadratic equation, and is now going to give you two solutions. So the only two ways we can get this is to come up with the factors of x minus 5 times x minus 2. So I'm going to set each of these factors now equal to 0. And when I do that, I'm going to get x is equal to 5 here. And over here, I'm going to get x is equal to 2. You can add 5 to both sides and show that to be the case, or you can add 2 to both sides and show that to be a case. But for this problem now, we need to do a check and make sure that these solutions are going to work. So I'm going to go ahead and when x is equal to 5, we're going to see what we get for the original problem. So here's the original problem. When x is equal to 5, we have 5 equals 5 minus 1 plus 3. 5 equals, well, 5 minus 1 is equal to the square root of 4 plus 3. 5 equals 2 plus 3. And yeah, 5 equals 5. That check works out. Let's make sure the other number works too. So when we have x is equal to 2, let's see if this works out. So we have 2 equals 2 minus 1 plus 3. Well, 2 equals, let's see, the square root of 1 plus 3. 2 equals 1 plus 3. But here I get 2 equals 4. Now, we know that doesn't work. So we are going to reject 2 as a possible solution to this problem. In this problem, the solution of 2 that we obtained simply doesn't work. So we're going to accept that x equal to 5 is our only solution to this. So not every solution that you calculate using this technique is always going to work out nicely. It just is not going to always work out to be the case. So we're going to go ahead and take a look at 2 more problems that are a little more sophisticated, and let's see how we can muddy our way through these. Well, let's go ahead and take a look at 42. This is going to take the better part of a page, so if you are at the halfway point or some other place, I recommend going to a new page on this before beginning to copy this down. So this is going to be 3 plus the quantity of z minus 6 equals the quantity of, or the square root of z plus 9. Before we get started in this question, I'm going to double check to make sure that I've copied everything correctly. I don't want to have to start a question like this all over again. So we will in fact have to square both sides. Squaring the right side is not a big deal because that's just going to result in z plus 9. But squaring the left side is not going to be pretty. This is going to require significant work. So let's do this work over to the side here. So here we have 3, and we have radical z minus 6. Here we have 3, and then radical z minus 6. So 3 times 3 is going to be 9. 3 times this is going to be 3 radical z minus 6. This is going to be 3 times radical z minus 6. And then radical z minus 6 times radical z minus 6 is going to be z minus 6. So we've got a little consolidating here to do. So again, feel free to watch this part as many times as you like. You will probably find that to be helpful. We have 9 plus z minus 6. Well, 9 minus 6 is 3. So we're going to have z plus 3. And then here we'll have 3 times z minus 6 plus 3 times z minus 6. So that'll be plus 6 times radical z minus 6. And I'm going to take this over here and put it on this side. Now at this time, I can't take the 3 and the 6 to add them together because 6 is multiplying the quantity of z minus 6. But what I am going to try to do, as much as I can, is I'm going to try to get this radical by itself. So, how we do that is the following. First, let me subtract z from both sides. And let me subtract 3 from both sides. When I do that, these both disappear. Here even the z disappears. 9 minus 3 will be 6. And here I'm even going to get 6 times z minus 6. Now, sometimes it works out nicely. So I have 6 times this, and here I have 6. Sometimes you just have to square this as is. Sometimes you can even do a little more fancy work. Divide both sides by 6, and now we get the result of z minus 6 is going to be equal to 1. From this, we can now go ahead and square both sides. And we're now going to get z minus 6 is equal to 1. And when I add 6 to both sides, we're going to get z is equal to 7. And that, in fact, does turn out to be our solution to question number 42. Sometimes in these problems, we get questions that are a little more difficult. So let's go ahead and take where there's more work to it. So let's go ahead and take a look at one more such problem to see how this work kind of comes together. And then we're going to take a look now at question 46. So in question 46, we have the square root of 6x plus 7 minus the square root of 3x plus 3 equals 1. So the last thing you want to do with a question like this is to try to square two different radical terms with binomials under each. It's crazy. We're going to go ahead and move one of the radicals to the other side and then square everything. So I'm going to add the quantity of radical 3x plus 3, or excuse me, not this, add radical 3x plus 3 to both sides. So we're going to get radical 6x plus 7 equals 1 plus radical 3x plus 3. So now the problem looks more like the problem we just did, but we need to move one of the radicals over to the other side. That's an important step here. Now we're going to go ahead and we're going to square both sides. So in squaring both sides now, we'll get 6x plus 7 here. Now in this part, again, big box will probably prove to be helpful. So I have 1, and I have 3x plus 3. 1 radical 3x plus 3. 1, 3x plus 3. Now 1 times this, so this is going to be radical 3x plus 3. This is going to be radical 3x plus 3. When we consolidate this, now 1 plus 3 is 4, plus 3x, so it's going to be 4 plus 3x, plus, here's 1, so it's 2 times radical 3x plus 3. So that's what's going to be here. 4 plus 3x plus 2 times radical 3x plus 3. Feel free at any time to stop the video or listen to something a second time to see an explanation of this. And yeah, you'll see there's quite a bit of work here. Well, again, we're going to try to get the radical by itself. So I'm going to subtract 4, subtract 4, subtract 3x, subtract 3x, and let's see what we get. This will be 3x. This is going to be plus 3 equals, oh, one can only help here. It's going to be 2 times radical 3x plus 3. So one may get your hopes up and say, oh golly gee, can't we do anything because this is out there and that's under the radical? No. we're going to have to square both sides again, and it means we're going to be stuck factoring a quadratic in this one. So we're going to live with this as is. When we square this side, the 3x plus 3 is going to work out of the radical, but we have this 2 now. And that 2 when you square it is going to be a 4. And now we have to multiply 4 by 3x plus 3. So it's not as simply just getting rid of the radical. We have to square the 2 also. And now we have to multiply 4 by this. So when we do that on this side, we're going to get 12x plus 12. Over here, when we take 3x plus 3 and we square it, this is going to be a little bigger. So we have 3x plus 3, 3x plus 3. When we multiply, this is 9x squared plus 9x plus 9x plus 9. So here we're going to get 9x squared plus 18x plus 9. And now that we have a quadratic equation, again, we want to get this equal to 0. So I'm going to go ahead, I'm going to subtract 12x from both sides. And I'm going to subtract 12. So this is going to give me 9x squared minus 6, or plus 6x minus 3. So looking at this, we realize, ooh, this is not going to be a real pretty quadratic equation. We're going to set it equal to 0. Now we need to solve this. So to solve this now, first let's just move this over here. One thing we can do to simplify this significantly is go ahead and factor 3 out of this. So it'll be 3 times 3x squared plus 2x minus 1. And that's going to equal 0. This is a key step. Don't forget this. I want to get rid of this 3. So I'm going to divide by 3. 0 divided by 3 is still 0. And I'm going to be left with 3x squared plus 2x minus 1. Now, there's only 2 ways to get negative 1. That's going to be plus 1, minus 1. But you want to come up with the right combination. And there's only one way to get 3x squared, 1 times 3. You need to come up with the right combination of this. So I'm not going to teach the factoring. I'm just going to do the factoring to show how we get to the answer. So this is going to be 3x here. This is going to be x here. If you check, 3x times 1 will be 3x. X times negative 1 will be negative x. That'll be plus 2. So I know these are going to be my 2 factors. So when I come up with this now, I'm going to take x plus 1, set it equal to 0. 3x minus 1, set it equal to 0. Here I'm going to subtract 1 and get x equals negative 1. And here I'm going to add 1, 3x equals 1. I divide by 3, and that's going to give me x is equal to 1 over 3. So I have 2 solutions to this now. X is equal to negative 1, and x is equal to 1/3. We're going to go ahead and I'm going to check both of these answers. I'm going to move this up a little bit. So I'm going to write down the original form of the equation here. And I'm going to check both of these solutions. I'll just kind of do that here. So the original equation is going to be, let me just write this actually down on a fresh page here. The original form of the equation is radical 6x plus 7 minus 3 radical 3x plus 3. We want to see if that's equal to 1. The first solution we're going to go ahead and check is when x is equal to negative 1. So we're going to replace it in now. So this is going to be radical 6 times negative 1 plus 7 minus 3 times, whoops, the square root of 3 times negative 1 plus 3. And see if that equals 1. Hey, hon, I'm taping. Okay, so this is going to be 1 minus 3 times negative 1 is negative 3, plus 3 is the square root of 0. 1 minus 0 is equal to 1. And yeah, this solution works out. So that passes our check. The other video we have, or the other number we have is when x is equal to 1 over 3. We're going to go ahead and substitute that number in. So here we have 6 times 1/3 plus 7 minus 3 times 1/3 plus 3. We want to see if that equals 1. Well, 1/3 of 6 is going to be equal to 2. 2 plus 7. 1/3 of 3 is equal to 1 plus 3. Radical 2 plus radical 7 is radical 9. Radical 1 plus 3 is equal to radical 4. Radical 9 is equal to 3. Radical 4 is equal to 2. And that check also works out. So you'll see that this is the one type of problem that holds by far and beyond the most work. The work for it itself almost takes up a couple pages. I'll usually include one question or two questions like this in your homework, and you will also see one question like this in your exam. This concludes the work that we are doing in Chapter 10 of the work we are doing up to spring break. Let me know if you have any questions. Thank you.